Hello students, I welcome you all in the third video of Laws of Motion. Students, in this video we'll continue with laws of motion, and our today's topic will start with is velocity time graph for non-uniform motion. When we'll talk about non-uniform motion, here the graph is drawn here. When you will see in this graph, students, in last graph we calculated the distance covered in uniform motion, velocity time graph in uniform motion. Here students, when you will see this diagram, a object starts from A and moves till point B. A object starts from A and moves till point B. Here initial velocity of A is 16 meter per second, and the velocity increases, and when the point is at B, its velocity becomes 32 meter per second, and time taken for change in velocity from 16 to 32 is 10 to 20. Initially 20 minus 10, when we'll get time. It is time taken is total 10 seconds, students. This change in velocity is done in 10 seconds. So here what we have to find, the distance covered. Suppose we have to find distance covered from between point A to B. So how will we calculate the distance covered from traveling from point A to point B? So for that, what we'll do, students, here when you will see this diagram, you will come to know that the initial velocity is 16, that is u is 16, and final velocity is 32. We are having two velocities, so we'll find the average velocity. And for average velocity, what we'll do, initial velocity plus final velocity upon 2. Here initial velocity is 16, final is 32, and whole upon 2. So when we'll add initial and final velocity and upon 2, we'll get the average velocity, students. We'll get the average velocity. So here 32 plus 16, 48 upon 2 will get 24, students. Will get 24. So here we are having average velocity. Now we have to find distance, students. When we are searching for distance, we need to have we will use the formula, students. Here distance velocity is equal to distance upon time. In this formula, when you will change the side of t, you will get distance is equal to velocity into time. So here velocity we have already 24 meter per second. We took the average velocity, but time, what is time? When you will see this graph, time taken is 10 seconds, students. So it started to accelerate from 10 second to 20 seconds. So we'll subtract, we'll get total time is here 10 seconds, students. When you will see total time is 10 seconds, students, here. So here time is 10 second, average velocity is 24. So distance covered is equal to velocity into time. Velocity is 24, time is 10. When we'll multiply, we'll get 240 meter. So distance covered will get 240 meters, students. This is the normal way we are using formula with the help, sorry students, just a second. Yeah, uh, here we did with the help of formula. Here, students, we did with the help of formula. What we did, we were knowing that velocity is equal to distance upon time, so we have to calculate distance, so we can use formula distance is equal to velocity and time into time. So here we had to find velocity and time, and then we can multiply and get the distance. So to find velocity, what we did, we took the average velocity. Here the initial velocity was 16, final velocity was 32. So we took 16 plus 32 and we divided it by 2. We got the average velocity 24. Now we are having velocity. Later when we'll find time, when you will see graph, you will find at A it was 10 second, at B it was 20 seconds. So here gap is of 10 second, that means time taken is 10 seconds, students. So here we are having time also. So when we'll multiply velocity and time, that is 24 and 10, we'll get total distance 240 meter. But students, when we are using the graph, we can directly find the total distance traveled without using any formula here, formula of velocity or distance. We can directly find the total distance covered. Let us see how to find the distance covered with the help of graph, students. With the help of graph, here what we'll do, students, when you will see here, a quadrangle is formed, as we learned in last video of last session, last part of the last video. We saw, we calculated the area of quadrilateral and we got the distance traveled. In the same way, here also we can calculate the distance traveled by calculating the area. Here when you will see, we are having quadrilateral A, B, C and D, A, B, C, D. So here we'll find the area of A, B, C, D, students. We'll find the area of A, B, C, D. We'll find the area of A, B, C, D, students. Here area of A, B, C, D is consist of two parts. One triangle is there, one quadrilateral is there. So we'll write area of A, B, C, D is equal to area of quadrilateral AECD, AECD plus area of triangle ABE, ABE. So I'll write ABE. I'll repeat again, students. I'll repeat again. Here we have to find the area of this quadrilateral. We'll find the area of quadrilateral. We'll get the total distance traveled between A and B. If we have to find total distance traveled from A to B, what we'll do, students, we will find the area of this quadrilateral ABCD. So here area of ABCD is consist of two parts, students. One quadrilateral is there, one triangle is there. So we'll write area of quadrilateral ABCD is equal to area of AECD. AECD is there down this quadrilateral, so I'll write AECD plus area of triangle, this upper triangle ABE. So I'll write ABE, students, ABE. So in this way, we can write area of quadrilateral is equal to quadrilateral AECD plus ABE. Now AECD, area of AECD can be calculated with the formula length into breadth. Here you can see, here length is equal to length and breadth. Here DE is 10 and AD is 16. When you will see, calculate AD, it is 16, students. It is 16. And here base CD, when you will check for CD, CD is 10, students. CD is 10. So here we will multiply length into breadth, 16 into 10 plus this is the area of AECD. Now what about area of triangle AB? We know area of triangle ABE is equal to half into base into height. So here half 1 upon 2 into base. Base is 10 here, students. When you will see this triangle, base AE is equal to DC and that is 10. Here base is 10, students. Here base is 10 and here height, when you will calculate, height is 32 minus 16. 32 minus 16 is 16. 32 minus 16, when you will get here 32 minus 16 is equal to 16. So height is 16. So we'll write half into base 10. I'll write 10 and height 16. So height I'll write 16, students. So when you will solve this, you will find 16 into 10. Just a second, students. Just a second, I'll just rub it out so that it will be clearly visible to you. Here 16 into 10 will get 160, students. Will get 160 and here again 16 into 10 160, half into 160 will get 160 plus 2 8 are 16, 80. So we'll get total 240. We'll get total 240, students. So here this is answer. We are having answer 240, students. So when you will see, it was 240, again it is 240. So that means we got the same answer, though we are using formula method or this graph method. So we can calculate the distance traveled, from point A to B by calculating the area of this quadrilateral, students. So here now you will say what is the need of learning this. Here we have learned this graphical method to find the distance traveled. We are going to use this method while deriving the formula of Newton's laws of motion, students. Today now we'll continue with Newton's laws of motion. Students, there are three Newton's laws of motion given by Newton, students, and these laws of motions are V is equal to U plus AT, V square is equal to U square plus 2AS, and S is equal to UT plus half AT square. I'll give proof of this all three with the help of graphical method, but at present you have to make sure that you will by heart these three equations. Students, these three equations are going to be there with you till you will study science in your future, students. Especially when you are taking physics after 11th, 12th, you will have to face these three formulas. A lot of use is there, so you will make sure that you will learn these three formulas, students. Here, students, when you will see S is nothing but displacement, U is the initial velocity, V is a final velocity, students. A is the acceleration, and T is a time, students. So here what you have to do basically, students, you have to by heart these three equations. These are the three equations of motion given by Newton. These are famous as Newton's equation of motion, students. Now I'll give the proof how these formulas are derived with the help of graph, students. Here, derivation of Newton's equations of motion will continue with. Students, suppose we are having initial. See here, the object starts from the point D in the graph with the velocity u. Object starts from point D with the initial velocity u, and it moves till the point B with the final velocity v here. So u initial velocity is given by OD is equal to u, so initial velocity u will be equal to OD, and final velocity v will be equal to OC. So here we'll get v is equal to OC, students. V is equal to OC. Now acceleration, students, total time taken from D to B. When object is moving from point D to B, total time taken here, time taken is equal to T, students. Total time taken is equal to T. Total time taken is equal to T, students. So here we are having initial velocity u is equal to OD, final velocity v is equal to OC, and time taken is equal to OE. Students. Time taken T is equal to OE. Now acceleration. We know acceleration is equal to change in velocity upon time. Change in velocity means final velocity minus initial velocity, time as it is. Students, in final velocity we are having OC, initial velocity we are having OD. So we'll write OC minus OD upon T. Now here in this formula, students, in this graph, when you will see OC minus OD. So here we are having OC minus, if I'll cut this part, OD, what is left is CD, students. What is left is CD. So we'll get is equal to CD upon T, students. CD upon T. So here we got A is equal to CD upon T. So we got A is equal to CD upon T. Students, we just change the side of T. We'll get CD is equal to AT. Students. I'll repeat again. When you will see OC minus OD, here this is OC. From OC, if we will cut this part OC minus OD, so what is left is CD, students. So here we can write is equal to CD upon T. t. So here we are having acceleration a is equal to cd upon t. I'll write here, students, a is equal to cd upon t, students. When you will change the side of t, cd will become is equal to at, students. Cd is equal to at. So this is same, it is written over here, students. Cd is equal to at. So we got cd is equal to at, students. We got cd is equal to 80 in this equation. Now here draw the line parallel to y-axis passing through. Here these parallel lines are drawn. These parallel lines are drawn, students. Now what we'll do here, when you will see v, when you will see final velocity v, this final velocity v is nothing but equal to OD plus CD. OD plus CD. So we can write V is equal to CD plus OD. So I'll write CD plus OD. Same thing is written over here. When you will see, students, V is equal to CD plus OD. V is equal to CD plus OD, students. V is equal to CD plus OD. Now here CD, what is CD? CD, when you will see, CD is nothing but 80. CD is nothing but 80. Just now we got. So I'll substitute the value. I'll get CD is equal to 80, and OD is nothing but U, students. OD is nothing but U. So OD is nothing but U. When you will see the equation, we are having OD is equal to U. Now when you will see the final equation, students, here V is equal to U plus 80. Sorry, students. V is equal to 80. V is equal to 80 plus U. V is equal to 80 plus U. Now I'll show you here. V is equal to 80 plus U. This is our first equation of motion. This is our first equation of motion, students. Now let us continue with the next. Now suppose we have to calculate the distance traveled from D to B. Now we know how to calculate the distance traveled. We have to calculate the distance traveled. We can calculate the quadrilateral area of this quadrilateral. We can calculate. We'll get the distance traveled, students. Just now we saw in the starting of this video, students. So here what we'll do, we'll find the area of DBEO. DBEO. So let us find the area of DOEB. See here, we'll find the area of DOEB. This whole quadrilateral area will find. But area of this quadrilateral consists of two parts. One this rectangle plus one this triangle. So here rectangle is DOEA, DOEA plus DAB. So here we are having triangle DAB and we are having rectangle DOEA. Students. So here what we'll do, students, we'll find the area of DOEA. DOEA area is length into breadth. Length here T, and breadth, when you will see, it is equal to U, students. It is equal to U. So we'll get here length OE into AE. OE into AE. OE is nothing but T. So we'll get T, and AE is nothing but equal to OD is nothing but U. So AE will get U, students. AE will get U. Now area of DAB. Let us continue, students. Here area of DAB. When you will calculate area of DAB, half. So half base is AD. Base is AD, and height is AB. AB is height, so AB is height. So half base into height. Now half as it is, students, half as it is. AB value, when you will see, AB value is nothing but equal to CD. AB value is equal to CD, and CD we have already calculated in our last video. I'll show you. CD we have already calculated 80. CD is AD. In last slide we did Now let us move to the same slide. Here CD is equal to 80, so I'll put the value CD is equal to 80, students. When you will see CD is equal to 80, I'll repeat again here, students. AB is nothing but CD is equal to 80, students, is equal to 80. We have already calculated, so I'll put the AB value 80. When you will see DA is nothing but OE, and OE is nothing but T, so we'll get is equal to T, students. So when you will put the value, you will get S is equal to UT plus half 80 into T, 80 square. S is equal to UT plus half 80 square. So this is our second equation of motion. This is our second equation. See here, students. S is equal to UT plus half 80 square. So we did first one. We did this last one. Now middle one is left. Let us do middle one, students. Let us continue with the middle one. Here, students, again same diagram I am using. Here again we'll find the distance only. Here we have to find the distance between D and B. When we will calculate the distance between D and B, we will have to calculate the area of this quadrilateral. So I'll write same. Now here we'll take it this quadrilateral as a trapezium. When you will see the opposite, one pair of opposite sides are parallel over here, students. Here one pair of opposite sides are parallel. When you will see this quadrangle, opposite side pair is parallel, other side pair is not parallel, so it can be taken as a trapezium, students. This is a trapezium. So as a trapezium, we can calculate the area by the formula S area, this area of DOEB, that is trapezium, is equal to half into sum of parallel sides into distance between the parallel sides, students. Sum of parallel sides into distance between the parallel side. Now sum of parallel side means OD plus BE. OD is U and BE is V, students. BE is equal to this OC. BE is equal to OC, that is nothing but V. So here U plus V, so we'll get U plus V. Now the distance between the parallel lines, over here is nothing but OE, students. OE, that is nothing but T, so we'll write T, students. Here here S is equal to, students, when you will see this, I'll stop the equation here only. Now we'll talk about acceleration, students. I'll stop the equation here only. Now we'll talk about acceleration. Acceleration is nothing but final velocity minus initial velocity upon T. Change in acceleration velocity upon T. Now what I'm doing in this equation, students, I'll just change the side of T and I'll just change the side of A. A will come in denominator, T will go in numerator. We'll get T is equal to V minus U upon A. This value of T I'll put over here in equation 2, students. So here S half U plus V. Instead of T, we'll get, students, T value V minus U upon A. Students. Now here, students, I'll just modify this equation. Half 2 will go in denominator, A will go in denominator. So we'll have in denominator 2A. Students, we will have 2A in denominator. Now V plus U, V minus U in numerator. Students, we know formula A plus B, A minus B is equal to A square minus B square. This formula is known to us, we have learned in algebra. So same will happen here. V plus U, V minus U. See here 2AS. What I'll do here, students, I'll change the side of 2AS. 2AS side I'll change, students. When I'll change the side of 2A, it will become 2AS, students. And what will left on right hand side is V plus U, V minus U will left on right hand side. Now we know formula V plus U, V minus U is V square minus U square. So we'll get V square minus U square is equal to 2AS. Here 2AS is equal to V square minus U square, students. You just change the side of minus U square, it will become plus U square, students. So it will become U square plus 2AS is equal to v square. Same equation can be written as v square is equal to u square plus 2as. Students, this is our third equation of motion. This is our third equation of motion, students. V square is equal to u square plus 2as. Students, for today I'll stop here only. In next video we'll continue with the chapter, students. So please don't forget to see the next video of laws of motion. By the time, I'll say thank you to you all. We'll meet in next video, students. Thank you very much, students.